The AI animation scene just exploded. Whether you're making AI comics, AI shorts, or long-form AI video, this is the one model you cannot miss today. It's called MiniMax H3, one model that understands text, images, video, and audio at the same time, and then generates video with dialogue, sound effects, and a score in stereo. And it runs inside ComfyUI on your own machine. Today, what it is, how to install it, how to actually read the workflow, and at the end, I use it to make a 30-second wuxia short film. First, what it is. MiniMax H3 is an omni-modal generation model announced on July 31st. On August 3rd, they released the open weights and the community went straight into a frenzy. Here's the point. This is not just another text-to-video model. Before, you'd pick one model for the picture, another for the voice, another for sound effects, and then line up the timeline yourself. H3 puts text, images, video, and audio into one shared context and generates the picture and the stereo audio together. Lip sync, footsteps in the snow, the ring of a blade, the background score, all from the same single pass. Quick spec run. 15 seconds per clip, 24 frames per second, 32 kHz stereo. Aspect ratios from cinematic 21:9 all the way to vertical 9:16. Dialogue is stable in 11 languages, and Chinese is one of them. Here's something most videos leave out. H3 is actually a 3-tier system. A cloud understanding layer, the downloadable generation core, and a high-resolution layer that reaches 2K. The only part you can pull down to your own machine is the middle one, so local output is basically 768p. For 2K, you either go through the official API, or you bolt a separate upscaler onto your local pipeline. Now the license, and if you're watching this in English, you need to pay attention. This is a custom community license, not a normal open source license. It names the European Union, the United Kingdom, South Korea, and the United States as excluded territories. If you are in any of those, and most of you watching are, you need separate written authorization from MiniMax before you use it. On top of that, commercial products over $20 million a year need a separate deal, and your interface has to display the words MiniMax H3. Read the terms yourself before you ship anything. Installation. The good news is you don't need any third-party extension. ComfyUI supports this natively. Just update to 0.30 or later, and the template library already gives you 3 official workflows: text to video, image to video, and the strongest one, reference to video. You need to download 4 files. The generation core is about 21 gigabytes, the text encoder is 15, the video and audio VAEs together are 6. That's roughly 40 gigabytes for one set. Reference mode adds another 21. Clear 70 gigabytes of disk before you start. Here's a trap that will make you think the download failed. After you drop the models in, if ComfyUI is already running, the interface will tell you the model file is missing, even though the file is sitting right there. That's because it read the model list at startup, and it has no idea about anything you added afterwards. Don't re-download, just restart the service. I fell for this myself and went and checked the file sizes before I believed they were complete. One more thing to get right up front. Put these models on a solid-state drive. H3 moves weights between the GPU and system memory constantly, and a mechanical drive will strangle it. I was about to use my 7TB drive, checked, found out it was mechanical, and moved everything to NVMe. What hardware do you need? People in the community have forced it onto 8GB cards, but that's only good for low-resolution previews. 12GB lets you experiment. If you're serious, 24GB is the sensible entry point, which is what this 3090 is. Now the main event, the workflow. Open the official template and you might be surprised because it looks clean. Only 6 nodes. That's because the new version tucks the real thing into a subgraph and hides the complexity. But to actually understand it and change parameters, you have to go inside that subgraph. And in there, it's the full 15 nodes with wires everywhere. Let me break it into 5 blocks. Block 1, model loading, the generation core and the text encoder load separately. Block 2, text encoding, this is where your prompt becomes a signal the model can read. Block 3, the sampler, the engine that actually paints the frames. Block 4 is the interesting one, the audio-visual latent. Because H3 generates picture and sound together, this is where the resolution and the length of the whole clip get decided. Block 5, dual decode output. The picture goes through the video VAE, the sound through the audio VAE, and it all lands as one MP4 with audio. Understand those 5, and the whole spaghetti diagram is just those 5 things wired together. For parameters, copy the official baseline. 20 steps, sampler res multi-step, scheduler simple, denoise 1.0, get one run working with a fixed seed first, then go play. Sharp eyes will ask, where's the negative prompt? There isn't one. The official weights are distilled and run through BasicGuider, so the traditional positive-negative setup doesn't apply. Whatever you want to avoid, write it into the prompt in plain language. Avoid face swapping, avoid extra fingers, avoid text watermarks. Another trap every beginner hits. The length isn't whatever number you type. H3's frame count has to land on a 17K plus 5 grid. 124 frames is about 5 seconds, 243 is about 10, 362 is about 15. If you need an exact whole number of seconds, generate a bit long and trim it in post. Image to video has one more big trap. Your first frame gets stretched to fill the entire canvas, so if the aspect ratio is off, the face comes out wide. The fix is simple. Crop the image to the generation size yourself before you feed it in. This single step will do more for you than 10 rounds of prompt tweaking. And now H3's real killer feature, reference mode. You can feed up to 9 images, 3 video clips, and 3 audio clips at once. The way you use it is to assign each one a job in the prompt. This image only controls what the character looks like, that clip is only a reference for the fight choreography, that audio only supplies the voice. The numbering has to match the actual wiring order, that's an official requirement. If it feels slow, Sage Attention officially claims around 2 times on newer cards, but this 3090 is an older architecture and I only got a bit over 10%, so I just ran it native. The real win is Turbo LoRa. Within a week, it went from 4 steps down to 2 or 3, and the official repo ships it, so you don't have to hunt for it. My strategy, Turbo for previews, 20 honest steps for the final. Let's build something. A 30-second wuxia short called Listening to Snow. A bamboo forest at night in the snow. A swordswoman comes to settle a score, breaks the formation with 1 strike, and finds out the masked man is the older brother from her school who vanished years ago. How do you get 30 seconds? You don't ask H3 for 30 seconds, its hard limit is 15 per clip. The right answer is 6 shots. Each one generates 124 frames, about 5.2 seconds, trimmed to exactly 5, and stitched together that's a precise 30 seconds. Shot 1 comes straight out of text to video, bamboo forest at night, the swordswoman enters. Then do one very important thing. Pull out the single frame where her face reads clearest and save it. That frame is the key to her face not changing in every shot after this. But there's a catch. In the frame I pulled, she's looking down at her sword, so there's very little face information and it can't hold the identity on its own. So I generated a separate front-facing character sheet with ChatGPT. Except the character sheet alone doesn't work either, because that face was painted by a different model, and cutting to it after the first 2 shots reads as a different person. The solution is to feed both. Reference mode takes up to 9 images, so I gave it the look from shot 1 and the front-facing sheet together, and I said it explicitly. These 2 are 2 references of the same person, not 2 characters. And then one more line, there is only 1 woman in frame, because without it, the model will very likely treat them as 2 people and hand you twins. But let me be honest about the limits. I cropped the face out of all 6 shots and lined them up. The first 4 are nearly identical. The last 2 are a little rounder in the face with slightly bigger eyes, because those 2 are close-ups. There are twice as many pixels on the face, so the model leans harder on the high-resolution character sheet, while the medium shots follow shot 1 instead. The 2 references are pulling against each other. So reference mode can hold you inside the same person, but don't expect a live actor with the exact same face in every frame. 2 ways to handle it: keep your shot sizes close to each other, or lock your key close-ups by continuing from a first frame instead. One more small story worth telling. I originally specified a worn silver sword, and shot 1 came back with a gold patterned hilt. I didn't regenerate. I changed my spec to match it and wrote the gold hilt into every shot after that. Continuity beats your original spec. As long as all 6 shots agree, nobody knows I wanted silver, but gold in one shot and silver in the next is a real visible mistake. All the fight coverage in the middle runs on reference mode, with the prompt written as time-stamped beats, like a director's script. You can even write the dialogue straight in. Chinese lines, lip sync, voice, all generated in one pass. Here are the speeds, and these are numbers I actually measured, not marketing. Preview at 864 by 480, a 5-second shot takes about 9.5 minutes. The real thing at 1344 by 768 takes 16.5. Look at that ratio. The resolution only went up 2.5 times, but the time went up more than 4, because attention cost grows quadratically. Never estimate this linearly. 2 findings here that are completely counterintuitive. First, you'd assume higher resolution means tighter VRAM. It's the opposite. The small size used 22.8 gigabytes and the large one used 21.6, because the new ComfyUI dynamically decides which weights stay on the card and which get pushed back to system memory. So VRAM looking nearly full does not mean you can't raise the resolution. The real variables are system memory and disk speed, not your GPU model. Second, I assumed more reference images would be slower. Also the opposite. Reference mode with 2 reference images took 16 minutes a shot, while image to video with a single first frame took 29, twice as long. Because that first frame has to be reconstructed exactly, and that's expensive, whereas reference images are just compressed identity information. So if you can use reference mode, use reference mode. And one genuinely alarming thing. With image to video, after you hit run, there's nearly 20 minutes with no progress at all, and it looks like the whole machine has frozen. It hasn't. That first frame has to pass through a 32 billion parameter vision encoder, and most of it is sitting in system memory, so that's just what it costs. Here's a really useful way to tell slow from actually dead. Watch whether the VRAM number is fluctuating. Rocksteady plus a pegged GPU means it's genuinely computing, so let it run. VRAM jumping up and down by hundreds of megabytes, that's when it's really stuck. Then, stitch the 6 clips together, swap in one continuous 30-second track instead of the music each clip generated on its own, and that's a wrap. To sum up, H3's real differentiator isn't how pretty the picture is, it's that it folds character, motion, camera, and sound into one generation language. Images control identity, video controls motion, audio controls the voice. That's the part other text-to-video models can't do. If you make AI comics, use reference mode to lock a character and let one character carry a whole series. If you make shorts, it supports 9:16 natively, so generate vertical instead of cropping a horizontal frame. If you make long form, break the story into 5 and 10-second shots and chain them with first and last frames. One last reminder on the license, the territory restrictions and the commercial terms are real, and if you're in the US, the EU, the UK, or South Korea, you need authorization first. Confirm it yourself before you publish. Powerful tool, but do your homework. The workflow, the parameters, and the full prompts for all 6 shots are in the description. Which would you rather see next, me using H3 for a comic series or for vertical shorts? Tell me in the comments. If you like this kind of hands-on testing, subscribe, and I'll see you in the next one.